Okay, we're finding derivatives for problems 14 through, well, more than that, but this, I am rambling. We're going to do problems 14 through 17 on this video, I think, because all we're doing is taking the derivative. Alright, so for number 14, we have two functions. We're going to, well, actually there's three, right? There's secant squared, that's one, tan is another, but secant squared is a composition of two functions. So we're going to do product rule and the chain rule for secant squared. So taking the product rule, going to keep the secant squared constant, meaning I'm not taking the derivative of secant squared right now, but I'm going to go ahead and take the derivative of tangent, which is going to be secant squared, plus, now I take the derivative of secant squared, so using the chain rule, so I'm thinking of secant squared like this, secant x raised to the second power. So this is in my thoughts. So I bring down the exponent of 2, subtract 1 from the exponent, and then take the derivative of the inside. And I'm running out of space, okay? So I've now, this is the derivative of secant squared, which means that I kept the tangent constant, and that goes there. All right, let's clean this up a little bit. So that's going to be secant to the fourth, and that's going to be secant squared, and there are two tangents, so it's tangent squared. I was wondering if this is going to do something weird, but I guess that's it. All right, and that's number 14. Let's go on to number 15. This one requires chain rule. There are three functions here. There's cosine, the outermost function. Then there's square root, one level in, and then the 4x squared plus 1, the third one. Okay, so take the outside first. The derivative of cosine is negative sine. Keep the inside constant. So I've kept the square root constant times, now when I'm ready to take the derivative of the square root of 4x squared plus 1. The derivative of square root is 1 over 2 times the square root of the inside. Okay, I was going to say something, but I forgot what I was going to say. Anyway, now I'm taking the derivative of the inside, 4x squared plus 1, which is 8x. Let's clean that up. So I want to move all this stuff either under or in the front, I guess. I don't know. Here, the 2's cancel, giving me 4. So I'm going to have 4x, negative 4x sine square root of 4x squared plus 1, and that in the denominator, square root of 4x squared plus 1 in the denominator. And remember, this square root of 4x squared plus 1 is in sine, so it can't cancel or reduce with its square root of 4x squared plus square root of 4x squared plus 1 in the denominator. Okay, I now recall what I was going to say about this. In case you don't understand how I'm getting the derivative, where this is coming from, I recall I took the derivative of square root of 4x squared plus 1. So this is just side note. I've already gotten the answer. This is just side note for square root of 4x squared plus 1. When I take the derivative of that, this function is the same as 4x squared plus 1 to the 1/2 power. When I take the derivative, so now this is derivative, I'm taking a derivative now. Okay, that's not a fraction bar, that's I'm dividing these two sections. Okay, so you bring down the exponent, keep the inside constant, and subtract 1 from the exponent, so that's negative 1/2. If I were to clean that up, that goes into the denominator. So there's nothing left in the numerator but a 1, and then 2 is in the denominator already. And that negative exponent becomes positive exponent. And that's the same as this. All right, so that's where I got this thing. Okay, this, right? If you don't know how to take a derivative without going through the powers, and that's perfectly okay. All right, changing it to a power is perfectly okay to use the power rule and all that stuff. I've just done it so many times I can go straight to that. All right, and hopefully you're nearly at that point yourself. All right, that's number 15, and I think that's plenty for this video.